Pluto's skyscraper-size methane ice spikes. New discoveries revealed by NASA. Pluto's equator may feature a geological marvel hidden to our eyes. A sprawling band of methane ice blades, some as tall as 100-story skyscrapers, covering an area 5 times as wide as the continental United States. But here's the surprising part. New research suggests these towering ice spikes blanket twice as much of Pluto as previously thought, spanning a 60% swath of its waistband. A groundbreaking study, just published in July 2024, reveals these frozen spires may extend to the dwarf planet's far side, hidden beyond New Horizons' high-resolution cameras. When the spacecraft made its 2015 flyby, it captured crystal-clear images of these bladed formations on Pluto's encounter hemisphere, less than half its surface. But scientists now believe similar structures may stretch across most of Pluto's equator, representing one of the most expansive ice formations in our solar system. These extraterrestrial confirmed soldiers differ vastly from Earth's penitentes, those jagged ice swords that reach just 9 feet in Chile's Andes. Pluto's blades tower approximately 1,000 feet and line up like soldiers in parallel rows, separated by miles. The study's lead author, Ishan Mishra of NASA's Jet Propulsion Laboratory, notes they form a surface variety so rough it creates distinct darkening patterns, even when viewed indirectly. But why guess? The evidence comes from clever analysis of light reflection and surface texture. When light bounces from rough terrain, it creates different brightness patterns than smooth surfaces. By comparing how Pluto's far side brightened under different angles, using New Horizons imagery, researchers detected telltale signs of blade-like roughness across methane-rich zones. This indirect geology suggested methane ice blades exist there too. Though scientists still lack direct visual proof. The catch? These ice formations need precisely right conditions, atmospheric methane that condenses and sublimates, ice turning directly to gas and back over Pluto's annual cycles. This process erodes the ice into blade shapes, similar to how Andean ice forms penitentes, but on a celestial scale. Similar structures might exist on Mars and Jupiter's moon Europa, but Pluto's is by far the grandest display. The study's most controversial claim: this blade terrain might stretch between 30 degrees north and south of Pluto's equator, creating a continuous ice blade belt. Yet it's unclear whether this band is seamless or broken into patches. To resolve this, Mishra emphasizes future missions are essential. Until then, he says, our research provides the strongest indirect evidence using available data. Would you prioritize sending a new spacecraft to investigate Pluto's hidden ice blades, or focus missions on more accessible worlds? Share your thoughts below. Study published in Journal of Geophysical Research Planets, July 5, 2024. Authors analyzed surface roughness patterns from New Horizons data, combining reflectance models to infer blade terrain presence on Pluto's distant hemisphere.